So, just really quickly, today's one of those days where we're gonna have a conversation, take a few notes, and then continue what we started last week. Because based off the quiz, there are some of us that are getting it, and some of us that maybe not quite so much. So I want to make sure, given the importance of slope and y-intercept, that you get it. Okay? Yes, sir. I have no idea, but I can look it up later because right now I'm talking about something else. Okay? So if you want to take notes, this will be a decent time to do so.
Okay.
I'm sorry? Some of it.
Some of it sounds like some of it. I forgot what some of the colors.
Brendan. Alrighty. Okay, so last week we started to kind of learn a little bit about the slope-intercept form, of an equation. And the slope-intercept form of an equation is what? What does it look like? Bennett?
Y equals mx.
Perfect. Y equals mx plus b. So we have y equals m times x plus b. Now, when we first started, we learned how to find the slope from a graph. How did we learn to find the slope, which is our m value? We learned to find the slope from a graph. How do we do that, Leilani? No.
Rise over run.
Rise over run. We learned that from a graph, we simply found the rise over the run. How fast, bless you, from one point to another, how fast, and again, remember, we're reading left to right, how fast it went up or down, or how far it went up or down, and then how much it went over. That created a ratio that tells us the mathematical measure of the slant of a line. It tells us what's called the rate of change. The rate of change is that slant. The rate of change is that slant. Okay, and it is a rate, and it is written as a fraction. The only exception being whole numbers, we can make them into fractions. And on a graph, how did we find the b value, Tara? Where it crosses the y-axis. Where it crosses the y-axis. Where it crosses the y-axis. Pretty straightforward, right? And then we went on the next day and we talked about tables. Tables. XY tables. And we learned how to find the slope from tables. How did we find the slope from tables, Cameron?
Change in y over change.
Very good. Change in y over change in x. The change in the y values over the change in the x values. We literally set it up. We measured the change in y and put it over the change in x. And then we simplified that fraction down. How would you find the y-intercept? How would you find the b value from a table? Brendan?
If it has the point 0 and then another number, then that would also be the b, but you could graph it. I think what he's trying to say is what he's trying to say is if the x is at 0.
That's what I'm looking for. If the x value is 0, because the y value is 0, that's not necessarily the y-intercept.
No, yeah, like if it says 0 in a number.
Yeah, you're looking for where the x, it's where the x value equals 0. That is the y-intercept. The y-intercept is located on a table where the x value equals 0. Any questions so far on this fun stuff? So this is our table stuff. And then once we identify all these points, We can set up the equation, no problem. So now we're going to talk about words. They are, and we sort of do. Some of us are better than others at it, though. Y-intercept. Given the fact that the slope is the rate of change, and the y-intercept is where it crosses the y-axis, where the x value is 0. In a word problem, where do you think we would always find the m value, the slope? In a word problem, where would we find the m value or the slope? Christopher?
N equals.
They'll never give you that. Jackson?
I'll give you two numbers, one being the rise and one being the run.
Nope. Nolan?
I was gonna say kind of like what Jackson said,
Nope.
but like
Brendan?
Kind of it.
Nope.
Well, it is.
I'm going to go to the movies. I'm going to take my family to the movie theater. And no, I'm going to go ahead and suck it up. I'm going to take them to the movie theater. I'm going to take them to a matinee, which means that all tickets are $4.50. All tickets are $4.50. But my only deal is to kind of minimize expenses. I'm going to make everyone share one bucket of popcorn for $12. What?
Oh,
Jackson?
well, so the popcorn would be the B, right? Because you're adding that.
Yes.
And then the M would be the amount of people. And then the X would be the price.
That would not be true. Ciara?
The other way around.
The slope would be the price per ticket.
That would be 9.
The slope becomes the price per ticket because it's the one part of our scenario that changes based off of how many people you take.
That makes it a line because once you're going up the thing, the people change on the graph and the price changes.
Yeah.
They go up.
Guys, here's what I need you to be thinking about, Gavin. You raised your hand, so I called your name.
oh, you want me to explain it, or can you?
No, we're already good.
Okay.
Okay, so listen to me. In a word problem scenario, the slope, which again, remember, the slope is a rate of change. The slope is a rate of change. The words that will help you find the slope in a word problem are the words per or each. It's the thing which changes based off of how many gallons of milk you buy, or how many people you take, or whatever. It's the amount that's going to change. I'll give you another scenario. If you go to Lifetime Fitness and you're going to sign up your family, Andrew McGee, put your head up and listen. Thank you. At Lifetime Fitness, when you go to sign your family up, they say, okay, we're going to charge you $125 a month. But there's a one-time only $200 sign-up fee, which kind of covers all your administrative costs and gets you signed up. So in that scenario, you don't have to raise your hand. In that scenario, your monthly fee is M. The $200 fee that only happens one time is your B value. Okay?
X is how many months to do it. Right?
Well, the B value becomes a few different things. It's sometimes called like the flat fee. If they say that there's a fee that doesn't change, that would be your B value. It can also be what's called the starting point. I'll give you a quick scenario on the starting point. Sally got a check from her grandmother for $50. She wants to buy her own iPhone. So she is going to start saving. She's going to start saving $10 per week until she gets to her number. So the equation would be y equals 10x plus 50. 50 is the check she got from her grandmother. Gets her started saving for that thing. And the $10 per month, 10x, that's how much she's going to save each. What does that make the x? Oh, did I say per week? Okay, so you're going to say $10 per week. That makes the X term, bless you, the number of weeks. Yes, sir.
Is that why the slope is called the rate of change? Because, like, basically, in the movie theater one, the price changes faster if a person, if a ticket costs more. So what that means is
Yeah.
why it's called the rate of
But I'll tell you something else, Jackson. If you think about that scenario, let's go back to the movie theater one, right? So if we were writing an equation based off movie theater, remember the tickets were $4.50 and the bucket of popcorn was $12. So we would say that the total amount that we spend, the cost, equals $4.50 per person plus 12, because I'm only buying one bucket of popcorn no matter what. I don't care how many people come. Even if 30 people come, they're getting one bucket of popcorn and they're going to share it because I'm cheap like that.
But you'll buy 3 people for them.
Yeah. Now, if you think about graphing this, where would we start to graph this, Brendan?
0, 12.
0, 12. So we would start at like 0, 12. And Jaden, from there, how would I get to my next point? Labib?
Up 9 over 2.
Up 9 over 2. Or up 4.5 over 1, right? I could have done either of those.
The slope has to be this one.
But they're equivalent. So what you end up with is a line that does this. Now I'll tell you something interesting. You know, a line basically goes in both directions. But in a real life scenario, this part doesn't exist.
Because you can't, like...
Because you can't have a negative number of people. Right?
Wow.
Yes, sir. No, ask your question, Bennett. Okay, I started at my y-intercept. That means my y-intercept is 12. That means the point 0, 12 is my y-intercept. I started there at the point 0, 12. And then from there, I use my slope, rise over run.
Okay.
How do I make a number into a fraction? Put it over 1. So then I can either go up 4.5 over 1, or I can convert it to one that's a little bit easier and go up 9 over 2. Okay? Now, I will tell you guys that an interesting thing, when you're dealing with real-life scenarios, this is generally the only quadrant that you can use. Because everything else represents a negative number. You can't have negative money, you can't have negative people, you can't have negative distance, you can't have negative time,
Well, what if you got paid?
you can't have negative height. I'm telling you that in a real life scenario, most of the time you cannot have negative measurements.
There's sometimes, but barely any.
So what that means is, if you see a graph of a real life scenario that looks like this, and you see they're asking you about the slope of a line that looks like this, and they say write the equation of the line represented on the graph.
Yeah.
But they won't say that.
They'll say line.
They'll say line, because they're really only giving you one piece of the picture.
So what number is that?
So where would you begin? What 2 things do you need to write the equation? B and M. So where would you start, Bennett?
At the right.
You would start here. That represents your B value, whatever that is. And then you would measure the slope. What do we know about this slope? It is a negative slope, because no matter which 2 points you choose, you would first do your rise, which is a negative value, then measure your run, which is positive. You would find that slope, and then you could write the equation of the line from this.
It would be y equals whatever that is.
Y equals negative something times x plus something.
Does that make it not a real life scenario? It could.
What? And what's flat?
The line.
No, it's not.
You don't know that.
That's a flat line.
No, I mean, in the slope, like, it's
I mean, it's less than.
like the slope.
I didn't write the scale. You don't really know what the scale is. Yeah. Andrew? Yes, get a drink of water as well, please. Okay? So, what we're going to do today, we're going to practice just finding slope and y-intercept and writing equations from graphs and tables. That's it. Tomorrow when you come in, we're going to do word problems. A lot of them. Because I need you to be able to find all those things we talked about. So make certain that you have this somewhere. That you know what things might represent our B value. The flat rate, the amount that doesn't change, the starting point. And that the rate of change, the per or the each guy, the per or the each number that you see in a word problem is typically your slope. Also, please pay attention to whether your per or each guy represents something that's increasing or something that's decreasing. If it says that so-and-so has $150 in her savings account and she is going to begin spending $12 per week,
Then the B would be the starting.
the B would be the starting point, $150, and
X would be the weeks, and then M would be the amount of money.
what is M?
12.
Wrong.
Negative 12.
It's negative 12 because she is spending it. And that is typically where kids mess up. That you're so excited because you see and everything's good, you don't pay attention to the word itself to know whether it's an amount that's going away or an amount that's increasing. Whether is it increasing or is it decreasing? So make sure you're careful with that stuff. Today we do not have homework. We only have the classwork. Okay? When you're done, just pack it away. Do not turn it in early. And then you are done for the day. Yes, ma'am. Well, you should easily finish. So there's really no part of home that's going to come into play. Okay? It's classwork I'm not allowing you to turn in. How about that? How about that? That's that.
What is that?
I had to ask too. I had no idea. I was like, I don't even know what that is. Okay?
Wait, can you leave that up?
Yeah.
Thank you.
Any questions?
You can have a negative slope as long as it's.
Y'all are always.
In a real life.
Shh, kiddos, listen up.
Oh, so you can have a negative slope as long as the y, as long as it's positive.
Yes.
Yes.
That means it's in the
Well, shh, now listen up. Shh, guys, listen to me really quickly. Bennett, listen up, please. There are situations where sometimes you end up in a real-life scenario with a negative B value. Say, for example, it says so-and-so is in debt, $1,000, and they're going to start saving $50 a week until they are no longer in debt. Yeah, then all of a sudden your B value, your starting point, is a negative number. So the bottom line is you just have to be careful and pay attention to the words themselves. Okay?